This PowerPoint is all about the compound angle formulae, or they're also known as addition formulae. But before we have a look at those, here's a quick starter for you to have a go at. There are two triangles that hopefully you know you've seen before that are really useful if you need to work out sine, cos or tan of 45, 30 and 60. So see if you can remember those two triangles and draw them. And then on the next slide I'll show you the answer. So press pause now, see if you can remember those on your own. So I'm now going to reveal the answers. Here they are. These are the two triangles. One of them is isosceles, the one on the left, so two of the angles are the same size. And the one on the right hand side has the 30 and the 60 on. The one on the right hand side started as an equilateral triangle with sides of 2, 2 and 2, which gives you those 60s in the corners. But then if we split it in half, it creates that 30, but more importantly, it creates a right angle triangle. So then you can do SOHCAHTOA. So moving on then to the compound angle formulae, also known as addition formulae. Here they are. They're in the formula booklet, so you haven't got to memorise them. You don't need to know the proof of where they come from. You just need to be able to use them. Now, what they do in the formula booklet is they write 6 different formulas in 3. Let me show you what I mean. If we look at the top one here, it's got sine of A plus or minus B. And then we have an expansion on the right hand side. Now in a question, let's say you were doing sine of something plus something, so A plus B. If you're using the top symbol on the left hand side, use the top symbol on the right hand side. So this would be sine of A cos of B plus sine of B cos of A. But if your question had sine of something take away something, so A minus B, this time we're using the bottom symbol on the left, so we'd have to use the bottom symbol in the expansion. So it would be sine of A cos of B minus sine B cos of A. So those two formulas are both contained within that one yellow highlighted formula at the top. The same thing happens for cos and tan. I'll write out the cos ones because I want to point out something important. In the cos formulas, if you're doing cos of A plus B, that means we're using the top symbol on the left hand side. In the expansion, the symbol that's on the top is actually a minus sign. So it's cos of A cos of B minus sine A sine B. And if you were using cos of A minus B, then following the formula, it would be cos of A cos of B plus sine of A sine of B. So you need to be very careful whether you're expanding something with a plus or a minus sign, and you need to decide, are you using the top symbol all the way through or the bottom symbol all the way through? I've just realised there's a symbol missing here, so I'm just going to put it in. That symbol should say minus and plus. So if you're doing tan of A plus B, then you'd have tan A plus tan B on the top, and then all over 1 minus tan A tan B. Or if you wanted to do tan of A minus B, it would be tan of A minus tan of B over 1 plus tan of A tan of B. So hopefully that makes a bit more sense. They've combined 6 different formulas down into 3. So now we're going to have a look at an example of why that might come in useful. So in this one it says, using the addition formulae, show that sine of 75 is equal to root 3 plus 1 over 2 root 2. Now I've put those two useful triangles on the side here. Remember, these are the ones with the 60s, the 30s and the 45s. So if we needed to work out sine of 60 or 30 or 45, we'd be able to do it easily using the triangles. But in this question, we haven't got 60, 30 or 45, we've got 75. So the trick on this sort of question is to split the 75 up into 2 angles that you know more about. So looking at the numbers that we know quite a lot about, 45 and 30 would be good ones to use for this, because of course 45 and 30 is the same as 75. Now we can use the formula from the formula booklet, the addition formulae, we're going to use the sine of A add B formula to expand sine of 45 plus 30. We could use 45 as our A and 30 as the B. So going through the expansion, it's sine of A cos of B, so for us that would be sine of 45 cos of 30, and then plus sine of B cos of A, so for us that's going to be sine of 30 cos of 45. The next thing we can do is work out all four of those by looking at the triangles. So for example, if you wanted sine of 45, you'd look at your 45 angle and you do sine is opposite over hypotenuse, so that's 1 over root 2. The next one is cos of 30, so if we go to the 30-degree angle, cos is adjacent over hypotenuse, so that will be root 3 over 2. So we can fill all four of those in using the triangles, and then we can simplify them. Remember that when you times in two fractions, you just times the tops and times the bottoms. So we end up with these two fractions. And because they've got a common denominator, we can write this as one big fraction with that common denominator on the bottom. And we can just simply add the tops. So we've proved what they asked us to prove in the question. We've got root 3 plus 1 over 2 root 2. So this is another example where we can use the addition formulae. This is a proof question. Show that something equals something else. So this type of question is where you want to pick a side to start from, either the left or the right, and try and show that whichever one you start with is equal to the other side. Now on this one, it's probably easier to start with the left-hand side because we've got some double brackets there which we could expand. So if we expand the double brackets on the left, we end up with these four terms. Now the next thing that you could do, this step is optional, but it could be helpful, is to reorder those terms. So if we put the sine A cos B next to cos A sine B, then we can spot that that is the yellow formula that I've just highlighted from the top. So that is the same as sine of A plus B. And then if we put the cos A cos B term next to the sine A sine B term, we can see that that is this one. This is cos of A minus B. So the yellow part is sine of A plus B, and the green part is cos of A minus B. And that is equal to the right-hand side, which is what we were aiming for. This next type of example involves solving an equation in which we need to use the addition formulae. In an exam question, they're never going to tell you use the addition formulae. You need to recognise on your own when to use it. And in this one, look, we can see that we've got sine of something plus something. So if we use those as our A and B, we could use the sine of A plus B formula to expand the left-hand side. So if we look at the left-hand side first, sine of theta plus 30, we can expand it using that highlighted formula. It's going to be sine theta cos 30 plus cos theta sine 30. And then we could work out some of those either on your calculator or using that triangle that we saw earlier. Cos of 30 is root 3 over 2 and sine of 30 is a half. So we could put those in and simplify the left-hand side. But so far we've only dealt with the left-hand side of our equation. We've now got to remember that this was equal to cos theta.